Everyone, so welcome to the second session for today, which is on attention. Is there attention without awareness? So the relationship between attention and consciousness, or between attention and awareness, has been an extremely hot topic for the last few years in the science and philosophy of consciousness. Here at the Tucson conference, I think a couple of times we've had sessions on, is there awareness without attention? Is there consciousness outside attention? Is consciousness just limited to what you attend to, or is there background consciousness that outstrips what you attend to? And here the results on change blindness and inattentional blindness and related phenomena become very relevant. Our topic for today is somewhat different. It's in some ways the flip side of that question. Is there attention without awareness? So the prior debate might as well go along with the idea that attention always involves consciousness. There's kinds of consciousness that go beyond it. Here the question is, are there kinds of attention that don't involve consciousness? And here both of our speakers have mapped out distinctive and opposing lines on this question. So I guess it's more or less set up as a kind of debate. Bob is going to take the yes side of the question. Yes, there is attention without awareness. And Jesse's going to take the no side. I mean, it's really nice to have Bob Kentridge here as our first speaker, because he's actually done really some of the pioneering work in this area in his studies on attention without awareness in Blindsight. And I think he might have presented on that topic at the Tucson conference really some years ago now. He's been coming back regularly ever since. So it's great to have him here today. Bob is very well known for his work in the psychology and neuroscience of Blindsight subject. He's been in psychology at Durham for many years, and great to have him to give his latest perspective on the question of attention without awareness. So, Bob Kentridge.
Oh, well, thanks, Dave, and thanks very much for inviting me back. It's always a real pleasure to come to Tucson. I first gave a talk about attention without awareness in Tucson, and I have the memorial T-shirt on. So, 98. Yeah. So, for those of you who were here in 98, there might be just a little bit that's repetitive, but I'll try and skim over it quickly.
Who was here in 98?
Yeah. Okay, so I'm going to talk about attention without awareness. And I always like starting these things historically. Here, before I start historically, here are the people who I must thank. And I'm going to rush along, so I'm going to thank them at the beginning so I don't forget to thank them at the end. Various people who've collaborated with me on some of the experiments I'll talk about today. So, how are attention and awareness related? We can go back to these guys, to Wundt and James, I guess the fathers of modern experimental psychology, and they disagreed about lots and lots of things, but in some senses I think they had fairly similar views on the relationship between attention and awareness. So they both commented on the fact that attention and consciousness are closely related phenomena. So James says, what's called our experience is almost entirely determined by our habits of attention. Wundt, we call that psychical process, which is operative in the clear perception of a narrow region of the content of consciousness attention. So they're really drawing some strong links between attention and awareness. They're not necessarily saying that they're the same thing, but they're drawing strong links. I could get a little bit more up to date. So here's a paper from, I suppose, the dawning of the new respectability of the scientific study of consciousness. It's a paper by Mike Posner. And one aspect of the paper is Mike Posner discussing the possibility that if we're looking for the neural correlates of consciousness, we might use attention as a proxy because it's easier to measure, it's easier to operationalize. So Mike Posner there, again, more up to date, is drawing a really strong link between attention and awareness. So how might attention and awareness be related? Well, they might be in identity. They might be absolutely one and the same thing. The processes that give rise to attention might be the same processes that give rise to awareness. In that case, if you see something, you must be attending to it. If you attend to something, you must see it. But there are some still close relationships between attention and awareness that could hold, but that don't necessarily imply identity. So there could be a necessity relationship, could be impossible to see something unless you attend to it. There could be a sufficiency relationship. It could be the case that if you attend to something, you inevitably see it. So here's a phenomenon. So you have to look at this picture and see there are some flashes that appear every now and then. There's something else that changes in the picture. Have you spotted it? Okay, look at the median divide. Okay, so this is one version of a change blindness phenomenon, and the explanation, or one explanation posited for your unawareness of the median divide switching between solid and broken is that those little flashing bits of checkerboard attract your attention. And because your attention is attracted to those rapidly onsetting checkerboards, you can't simultaneously be attending to the rest of the picture, including the median divide, and so you don't see it. And that would be an example of evidence that we might use to imply that attention might be necessary for awareness. So it might be the case that unless you're attending, you don't see things consciously. You're not aware of that change in the scene. That's not what I want to talk about. I want to talk about the other potential relationship between attention and awareness. I want to talk about the sufficiency relationship. So I want to ask the question, if you attend to something, do you inevitably see it? Now, if the necessity relation is true and the sufficiency relation is true, then that really means that attention and awareness must be more or less the same thing. I'm not going to argue about the necessity issue at all, but I'm going to discuss whether if you attend to something, you inevitably see it. And I think I'll explain how it was that I became interested in this. So I became interested in it because I was studying, as Dave said, a phenomenon called Blindsight. So that's a phenomenon that you find in patients who've sustained damage to primary visual cortex, and as a consequence of this damage, they're blind in the portion of the visual field that corresponds to their brain damage. But despite being blind, despite having no acknowledged awareness of visual stimuli in this area of the visual field, they can actually do simple visual tasks really very, very efficiently. I think the best example, the best way of getting this across is just to give you a debrief quote from a patient I was testing. So this is a Blindsight patient, GY. He's an experienced patient, and he thought we were doing a really rotten experiment. Said, I'd be none the wiser if you weren't putting any stimuli up just to fool me. I just listen for the beep and press a button. There's no point going on with this. I can't do it. So he's pretty sure that this is an awful experiment and there's nothing happening. Interestingly, on the block of trials that had just preceded this glum quote from GY, he'd got about 95% of the discriminations correct. And in a little while, I'll actually show you the experiment that this quote applies to. One thing that we were doing with GY, with this patient, is we were trying to map the spatial extent of his blind sight. So how far above his direction of gaze did his blind sight persist, how far below, how far out to the side, and so on. And so we were testing a whole series of different locations in his visual field. And here's another interesting debrief quote from GY. So when I'm testing neurological patients, I like talking to them about their experiences, and here's one of GY's debrief quotes. And he said, oh, when I realized that you were testing high up in the visual field, I tried to attend up there instead of the midline. You usually just test me with stimuli sort of straight ahead, but I realized you were putting the stimuli high up in the visual field, I tried to attend up there. And that seemed to me to be a pretty strange thing for him to say. So he's saying he was going to try and attend to a region of space where he had no experience. And I didn't really know much about awareness, consciousness, the relationship between attention and awareness at the time, but I knew enough to realize that that was a strange thing for him to say. So we took Mike Posner's absolutely standard spatial cueing paradigm, been used in the experimental study of spatial attention for 35 years. In this paradigm, we start out with a display where there's a spot in the middle of the screen, and we ask our subject to fixate the spot, and then an arrow appears, and the arrow indicates the likely location of an upcoming target. The arrow disappears, and then there's a target on the screen, and in this task, the subject's task is to report whether a line presented on the screen is horizontal or vertical. And in this case, you can see the arrow is indicating the likely location of the target truthfully. And the target, as I say, might be horizontal, might be vertical. But we also have some trials where the target appears in a misleading, in an invalid location. So the target might appear down here. Again, might be horizontal or vertical. And of course, the arrow could point in different directions. So the crucial thing that we compare is the performance when the cue, the arrow, accurately predicts the location of the target, and trials where it is misleading. And if there's an effect of spatial selective attention, then we'd expect performance to differ between those two conditions, so to be better when the arrow is truthful compared to when the arrow is misleading. For an experiment in Blindsight, we have to modify the procedure ever so slightly. The patient that we tested is only blind in half of his visual field, so he can see in central vision perfectly normally. So he can see the arrow, so we don't have to do anything about that, but he's not going to be able to see the targets that we present in his blind field. And so our modification to Posner's paradigm is simply to sound a tone at the point that the target is presented, and the subject's instruction is to report, or to guess, because that's what he says he's doing, to guess whether the line is horizontal or vertical as soon as he hears the tone. We've done quite a lot of versions of this experiment. I'll show you some data from the last of this set. So here, first of all, are the effects of cueing on accuracy. So how good is he at actually telling whether the line's horizontal or vertical? And we've got what are called two different stimulus onset asynchronies, so time intervals between the initial presentation of the cue and the presentation of the target. For both of them, though, you can see that when the cue is misleading, it's telling him the target's somewhere where it actually isn't going to appear, then his accuracy is slightly worse than when the cue correctly predicts the location of the target. All of these performances, all of these levels of performance are way better than chance. So this is an example of GY discriminating some simple visual property, but in the absolute absence of awareness. And it's actually this experiment that the quote I showed you earlier was from. So this is where he's getting things 80% correct, I think, in that block, and yet denying that there's anything going on in his vision. There isn't, however, any statistically significant difference between the valid and invalid cue conditions for accuracy. That's not the case, though, for reaction time. So here's the effect of cueing on reaction time, and you can see now when we present the target at the cued location, he's faster than when we present the target at the uncued location, and there's a stonkingly statistically significant difference at 450 milliseconds, and there's nothing much going on at 200 milliseconds, and that makes us very, very happy, because that's exactly what you would find in normal observers, that particular time course of this means of directing attention, when we're directing attention with a symbolic cue. So I could stop now, but it says I've got 17.25 minutes to go. So we could say, okay, well, we've demonstrated that attention is not a sufficient precondition for awareness. Go home. But it's true, it's in Blindsight. It's in a rather rare neurological condition, so perhaps we can't generalize. Brief digression. A friend of mine, Catherine Talon-Baudry in Paris, and her colleagues, some of whom, if you know the attention literature, you might realize know something about attention, essentially replicated this experiment in the same patient, but using magnetoencephalography to measure neural correlates. One tweak that they did was that we tried very hard to make sure that GY was completely unaware of our targets. They used very high contrast checkerboards that flashed on and off, and if you do that with a Blindsight patient, then sometimes he will say, well, I didn't see it, but I sort of know I'm not guessing. And so by using that manipulation, Catherine was able to manipulate both attentional conditions and conditions of reported awareness in the same study. And when she did that, she found that there were different components of the MEG signature that correlated with attention and with awareness in Blindsight. So the neural correlates of attention and awareness, in Blindsight at least, differ. But as I said, Blindsight is a rare neurological condition. Perhaps we can't generalize. So is the dissociation a peculiarity of Blindsight? So here's another experiment, and this is an experiment which we conducted with normal observers, with undergraduate students, as one does. We used a phenomenon called metacontrast masking, and this is a means of rendering a stimulus invisible. And so in this procedure, again, we fixate on a spot in the middle of the screen, and somewhere away from fixation, we present a colored disk. And in fact, the colored disk and the background have the same brightness, and the colored disk is pretty desaturated. It's very pale. Then that colored disk is only on the screen for a very short time, 30 milliseconds or so. There's a short gap, again, 30 milliseconds or so, and the disk is then replaced by a ring, colored ring, and the inside edge of the ring corresponds spatially with the outside edge of the disk. If you set up the timing correctly, the disk becomes invisible, so you really can't see it. And I remember when I was programming this experiment, at one point I thought, you know, I've done something wrong in the programming, there's nothing actually there, and I had to then turn all the contrasts up so I could see there really was something there. So you can get really effective masking like this. There's another interesting thing, though, that you can do with this phenomenon. If you ask people to report the color of the ring, and remember that's what they see perfectly consciously, it's influenced by the color of the disk, which they don't see. So there's a priming effect. If I measure how quickly people report whether this ring is red or green, they will be faster if the disk that precedes it is the same color as the ring. So we can measure behaviorally the effect of processing an unseen stimulus in normal observers. So what we did then was, I think this is my most complicated slide, is we constructed an experiment like this. So let's work backwards. So the subject's task is to report the color of rings that they see on the screen. Here there are two rings, they're both red. And in this experiment, the rings are either going to be both red or both green. And you can see a little bit beforehand, they're presented with these two disks, these two primes, one of which is the same color as the rings and one of which is a different color. And if the masking works okay, they won't see those two primes. And then sometime before that, we present them with an attentional cue, an arrow. And the arrow is meant to direct their attention either towards the prime that is the same color as the targets or the prime that's a different color. And so the logic of the experiment is that if we have succeeded in directing their attention and hence changing the extent to which one of these primes is processed relative to the other, we should be able to see the proof of the pudding in terms of the speed with which they report the color of the rings. So the prediction is that if we've actually demonstrated an attentional effect, then when the arrow points in the direction of the congruently colored prime, the matching colored prime, then reaction time to report the colors of the rings will be quicker than when the arrow points to the incongruent prime. Are you with me? That is the worst slide. The difficulty with this experiment, particularly for my poor subjects, is that if there are always two rings whose color they have to report on the screen, then in fact the arrow doesn't help them solve this task at all, because it doesn't matter in terms of reporting the colors of the rings whether they're attending down here or up there. The two rings are always both the same color. And if you do an experiment like that, people will soon learn to ignore the arrow. So poor subjects, we had to, as well as running trials that allow us to do our critical test, we also had to run an awful lot of trials where in fact there's only a single ring, and we arrange things so that the arrow actually is predictive of the location of the single ring. And the poor old subjects, because of this experimental design, had to do, I don't know, 5,000 trials in order for us to get enough trials of the critical dual target condition. So here are the results. And so these are just from the trials where there are the two rings, and what we're comparing are trials where the attentional arrow pointed towards the incongruently colored prime, so the one where the prime and the rings were different colors, with trials where the arrow pointed towards the congruently colored prime. And so we only ran 4 subjects because it was a mean experiment, meaner still, as you'll see in a second. Maybe it was overkill because there are incredibly significant differences in reaction time. So there's a really reliable effect of the direction, the validity of queuing. It is, as I say, a very mean experiment because having done this, we then revealed what was going on to our subjects, none of whom had realized. At the end, we debriefed them, but we revealed what was going on. And then we said, we're going to give you a whole series of trials now where the trials will come in pairs, and you'll see one trial where there are primes present and one trial where there are no primes present. And you'll see them in pairs, and I'd like you to tell me after each trial which of the pair had the primes in it. So that's temporal to alternate force choice procedure. And we ran another 5,000 trials. And they're at chance. So they can't explicitly tell you whether there were primes present. They're not aware of the primes, but we must have been able to manipulate the extent to which the primes are being processed with our attentional cue, because we've got this stonkingly significant effect that just depends on whether we're directing attention towards the congruent or incongruent prime. So, again, brief digression, we can do the same experiment, but rather than using an arrow as a cue, use a peripheral transient. So that's Posner's other means of controlling spatial attention. And this is not quite such a horrible experiment because attention should be captured automatically by a transient like that, so we don't have to do all of the extra single target trials, so we can run rather more subjects. Here are the results from the second phase of the experiment. You can see there's one guy who actually can tell when the primes are presented, so we removed him. And we analyzed the reaction times from everyone else, and again, you can see we've got a massive queuing effect, which disappears as the stimulus onset asynchrony, as the time between the presentation of the cue and the presentation of the target increases. And again, that makes us happy because that, again, is the pattern, the time course that you would expect for that kind of attentional queuing, that exogenous queuing. Okay, so attention is not a sufficient precondition for awareness in normal observers. And again, Catherine has done an analogous experiment in MEG and finds different neural correlates. Okay, so Can this conclusion be challenged, or can I go home now? Well, I think it can be challenged. And the crux of the challenge, as far as I can see, and as far as Jesse and Chris Mole and a number of other people have suggested, is that our subjects might have been attending, we might have been manipulating attention, and we might have been measuring awareness, but we might have been actually looking at two different things. So our subjects might not have been attending to and unaware of the same thing. Another way of putting this is that the objects of attention and awareness in these tasks might not have been the same. We certainly know that we can manipulate neural activity related to attention when there's nothing to attend to. We can still see a difference in neural correlates. So it might be the case that attending to a location in space is not somehow or other equivalent to attending to the objects at that location in space. As I say, Chris Mole and Jesse have written some really thought-provoking papers about this, and the thought-provoking papers were not only thought-provoking, but they provoked me to do a few more experiments. So here's the last set of experiments on a phenomenon called object-based attention. And I'll just take you through a basic object-based attention paradigm, Egley, Driver, and Rafal. And so here we've got fixation spot in the middle of the screen, and you can see there are two boxes, two objects present in the display. We present a prime, so just a light that suddenly flashes on, but then our subject's task is to report the color of a subsequent target. And the target could appear at the same location as the cue. It could appear over there, could appear over there. The interesting thing about this arrangement of objects, cues, and target locations is that this invalid target location and that invalid target location are equidistant from the cue. And what Egley, Driver, and Rafal discovered is that if the target is actually in the same object as the cue, you're a little bit faster than if the target is in a different object. So that suggests that in this paradigm, the unit of attentional selection isn't simply a spatial primitive. It's not simply the Cartesian, the retinal coordinates of the cue in space. It's actually the object. So these objects have been pre-attentively processed by the visual system, and it's the object that attention is being directed towards. And you can see here, this is typical data. People are quickest to do the color discrimination when the target appears actually at the cued location. But there is a difference between these two invalid locations, the within object and the between object. It's usually not a very big difference, but it's consistent. So here's our experiment. We start out with a display like this with randomly oriented little Gabor patches, little grating patches. And then after a little while, all of the grating patches resolve to produce a pair of objects. So you can see we've got two horizontal objects, and the objects are defined by the fact that they contain vertically oriented patches. The background is created of horizontally oriented patches. And we've got little gaps where we can present our cues and our targets. So far, so good. So now the interesting thing that we do is we make the objects invisible. So what we do is every 30 milliseconds, we rotate the orientation of the patches by 90 degrees. So all the patches in the background rotate by 90 degrees, all the patches in the objects rotate by 90 degrees. Means that there are always objects defined on the screen. So there's always a contrast boundary, an orientation contrast boundary around the objects, but they're actually alternating too quickly for you to be aware of this. And so what you see in a display like this is a display of little flickering checkerboards. So we ran this experiment, standard Egley, Driver, Rafal experiment, with our observers. We asked them after a block of trials what they'd seen. Here are the questions. They report that really all they see are the flickering plaids. There's no sense that they might be seeing the objects. But here's the reaction time data. So there's a really significant, again, consistent reaction time advantage when the target appears in the same object as the cue, even though the subjects haven't seen the object. So the object is the unit of attentional selection, but it's invisible. So there's something invisible that's been selected. Could we have got something wrong? So could some simple form of spatial selection still account for the effect, something that's not object-based? Well, I suspect that in the original version of the experiment, and in the Egli-Driver-Rafal experiment, this is possibly the case. So this is the arrangement of contingencies between cue and target presentation in the standard experiment. The target is more likely to appear at the cued location and equally likely to appear at either of those uncued locations. The upshot, though, is that the target is more likely to appear in the same object as the cue than in the other object, and if the objects are consistently appear at consistent locations on the screen, it also means that the target is more likely to appear on the same side of space as the cue. We can fix this, though, by adding another potential target location and just equating probabilities. And so now there can't be any spatial contingency, and yet we still get our RT advantage. It might yet be the case that, you could perhaps argue that, well, the subjects are not, it's not that the subjects are not seeing the objects, the subjects are perhaps learning about the locations of the objects, and they're learning to attend to an implicit representation of the objects. So we can prevent subjects from doing that by making the locations of the objects unpredictable from trial to trial. We know that you can redeploy object-based attention very rapidly. So here's a version of the task, and so now you can see we've got smaller objects, and in fact we've got all sorts of different locations and orientations that we can use from trial to trial. And if we do that, then the object location is unpredictable, yet we still get our RT advantage. So the final question is, if you're an experimental psychologist, you certainly won't be satisfied with our simple debrief. Did you actually see the things? So we did some signal detection experiments. So there's a signal detection experiment where we ask subjects to report whether they believe there are objects present in the display and give a rating, and we can then do a signal detection analysis, and a D alpha of something more than 0 implies that they are capable of detecting the presence of the objects, and you can see that D alpha, D prime is not significantly different from 0. We can make the parity between the attention task and the awareness task absolutely explicit by asking a different question. So now the explicit task that we're asking about awareness and the basis of the attentional effect are identical, and still these D primes are 0, still we have an attentional effect. So to conclude, 1 minute 36 over, attention is not inevitably accompanied by awareness, and that's true in Blindsight, it's true in normal observers, it's true whether attention is under exogenous or endogenous control, so whether we're using arrows or peripheral cues. It's true whether attention is directed at locations in space or at objects. Returning very briefly to Mike Posner's suggestion that one might use attention as a proxy for consciousness in studying the neural correlates of consciousness, well, that doesn't seem to be viable, because it certainly looks from Catherine's work that the neural correlates of attention and awareness, at least in these paradigms, differ. And finally, and I guess this is for neural correlates aficionados, but that object-based attention experiment really suggests that attention can be acting in relatively anterior areas of cortex, so not just in early extrastriate areas, and in the ventral stream, because we know that the locus of selection in that kind of object-based attention is in lateral occipital cortex in area LOC. And so with that, I'd like to conclude. I'd like to thank you for your attention, perhaps your awareness, but not necessarily.